Okay, this is a quick summary of metabolism. Very simple definition, all chemical reactions in the body. Quick reminder that energy is found in lots of places in lots of ways. Thermal energy is actually the motion of the smallest particles, the molecules or atoms of an object. Remember potential energy, right? The stretched elastic, the position of the hammer. Kinetic energy is actually energy of motion. And the energy is never created or destroyed, but it's converted. So I pointed out electricity because in the case of a windmill, the kinetic energy of the windmill will actually be turned into electric energy and so on. So what does this have to do with the human body? Well, the best analogy comes in a fire. Where does the energy of a fire come from? What is providing the energy? Same would be true of a stove, a gas stove. And so what do these two have in common? The fuel for your fire and the fuel for our bodies. What do they have in common? What kind of energy are they? They're a type of potential energy called chemical energy, right? When the log is burned and when we digest and burn, so to speak, our food, we extract the chemical energy of the food and of the logs, and chemical energy is found to be precise in the bonds. So the bonds between atoms contain energy. So that's why to extract the energy from something, you break it down. You just take apart from larger molecules to smaller molecules. So it's a breakdown, not a building up. Okay, here are a few boring definitions. Take the time to go through them. We'll use these two words a lot, anabolic reactions and catabolic reactions, so learn those. This is the famous reaction, which, by the way, it is the formula for combustion, and it is a simplified formula for cellular respiration. In fact, cellular respiration has many, 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 many complicated steps, but we're not covering those. We're just doing a real quick and simple version. So you can learn this version, and this is marvelously simple. In fact, you're reminded of the fact that every time we extract energy from any food nutrient, the most simple one being glucose, we use oxygen. You're reminded of that by the fact that you need oxygen continuously, and you have as a waste product carbon dioxide. You're reminded of that by the fact that you exhale carbon dioxide, right? And of course, why do we do this? To get energy. It's what fuels everything. And without it, we would not be able to stay alive. Okay. This represents all polymers, all large biomolecules. We have three in mind. You should know them well. Proteins, I'm going blank, proteins, carbohydrates, and lipids. When they are broken down, so this is a catabolic reaction, into their monomers, and make sure you know the corresponding monomer for each polymer. Proteins become amino acids. Lipids become fatty acids. And lastly, carbohydrates would become sugars. When you break them down, you give off energy because of what we said earlier, that inside the bonds there is energy. This diagram is imperfect. The one we did on the board is far better because we can connect this into a U. So look at or remember the one that we did on the board. Look at it in your notes. The next step is to take these monomers, which we can also call building blocks, and we will take them and use them to build new biomolecules. But the difference between these are the biomolecules we get from food, the new biomolecules that we're creating, which I'm pointing this way because instead of going this way, we had it in the shape of a U. It was not quite a full cycle, but it was a U. So when we go this way, we're using the monomers or the nutrients we get from food and building out of them the biomolecules that we want or need. Perhaps you're building proteins because it's an enzyme you need to make, or perhaps it's an antibody you're making, you're fighting a sickness, or perhaps you're just in the normal process of growth and repair. You're building more muscle, or you're repairing tissues from an injury, or tissues that have grown old. Whatever the case be, when we take smaller molecules, monomers, and build new biomolecules out of them, it's the process of growth and repair. This process, of course, is catabolic, and it consists primarily of digestion and then of cellular respiration in every single cell of our body. Digestion and cellular respiration are the primary catabolic reactions. The primary anabolic reactions are protein synthesis and lipid synthesis, kind of summarized by the general ideas of growth and repair. Okay. Okay, so that's just what I went over. You can look it over on your own. This we went over in great detail one day. You guys brainstormed, and this was my summarized list. And here is the famous chart that you had for homework. So I think it's just important to understand basic pathways, right? All these three pathways are digestion. These three pathways here are cellular respiration. All of them are blue. All of those are blue because they're catabolic. They're breaking down. They're breaking things down. And this is how we get energy. So we get energy from food using this pathway, and this pathway. Notice this one is distinctly shorter because it's the fastest, most immediate form of energy. Okay, when we don't have food, where do we get energy? Well, we start by using glycogen. That's the carbohydrate stored energy in our liver and in our muscles. And we do this. So this pathway gives us energy. Or we use fat storage. If we really haven't had food for a while, we're going to need to use our fats, break down our fats, and we'll get energy with this pathway. Or if we're really in, so to speak, starvation mode, we would break down our proteins, they're giving an example of muscles, and do that to get energy. Very important are these two green arrows, these two anabolic processes. What do we do with the nutrients we get from amino acids? We make new proteins, the proteins we want and need for growth and repair and for any particular enzymes and hormones and all kinds of other things that we need. And what can we do with the fatty acids we've digested? We can build new lipids. So for example, the lipids of our cell membranes, other lipids we might need in our body, and then also build up fat storage so that we have stored energy if we need it. Okay, this is the same diagram. These three are the wrong color. They should all be blue. They're catabolic reactions. This is another nice little summary. It should all make sense, I believe. And I think that is it for metabolism. Okay, take care. Bye-bye.